Wave-particle duality is a principle in quantum mechanics that suggests that all matter and energy exhibit both wave-like and particle-like properties. This concept challenges our classical understanding of the world and provides a framework for comprehending the behavior of light and matter at the atomic and subatomic levels. Picture this. You're in a boardroom at Apple's headquarters in Cupertino, California. Steve Jobs is presenting a revolutionary new product, the iPhone. He explains how this device is not just a phone, not just a computer, but something entirely new. It's both a communication device and a powerful computing platform, defying traditional categorization. This duality of the iPhone's nature mirrors a fundamental concept in physics: wave-particle duality. The main focus of this mental model is to understand how seemingly contradictory properties can coexist in a single entity. By grasping this concept, we can develop a more nuanced view of reality and apply this thinking to various fields beyond physics. Our objective is to explore how wave-particle duality can serve as a powerful mental model for understanding complex systems and phenomena in diverse areas such as business, psychology, and social dynamics. To learn about more mental models like this one, please like the video and subscribe to the channel. The concept of wave-particle duality emerged in the early 20th century as physicists grappled with understanding the nature of light and matter. The debate over whether light was a wave or a particle had been ongoing since the 17th century, with Isaac Newton proposing a particle theory and Christian Huygens advocating for a wave theory. In 1905, Albert Einstein proposed that light could behave both as a wave and as a particle in his explanation of the photoelectric effect. This work, which later earned him the Nobel Prize, laid the foundation for the concept of wave-particle duality. In 1924, Louis de Broglie extended this idea to matter, suggesting that all particles could exhibit wave-like properties. This hypothesis was experimentally confirmed in 1927 by Clinton Davison and Lester Germer, who observed the diffraction of electrons. The development of quantum mechanics in the following years further solidified the concept of wave-particle duality as a fundamental principle of nature, challenging our classical intuitions about the behavior of matter and energy. At its core, wave-particle duality states that all matter and energy can exhibit properties of both waves and particles, depending on how we observe or measure them. This concept is counterintuitive because in our everyday experience, objects behave either as particles, like billiard balls, or as waves, like ripples on a pond, but not both simultaneously. Waves. In physics, a wave is a disturbance that propagates through a medium, transferring energy without transferring matter. Waves are characterized by properties such as wavelength, frequency, and amplitude. They can interfere with each other, creating patterns of constructive and destructive interference. Particles. Particles are discrete units of matter or energy with definite mass and position. They behave like tiny billiard balls, following predictable trajectories and colliding with other particles. Duality. The term duality refers to the coexistence of these two seemingly contradictory natures, wave and particle, in a single entity. When light interacts with matter, it can behave like a stream of particles called photons. This particle-like behavior explains phenomena such as the photoelectric effect, where light knocks electrons out of a metal surface. However, light also exhibits wave-like properties such as diffraction and interference. These properties are evident in experiments like the double-slit experiment, where light passing through two narrow slits creates an interference pattern on a screen behind them. The same duality applies to matter. Electrons, typically thought of as particles, can also exhibit wave-like properties. This is demonstrated in electron diffraction experiments, where electrons create interference patterns similar to those produced by light waves. To help visualize this concept, imagine a person walking on a tightrope. From a distance, their movement might appear as a wave traveling along the rope, but up close, you'd see a discrete individual, a particle moving step by step. The person is both the wave and the particle, depending on how you observe them. The significance of wave-particle duality lies in its fundamental role in quantum mechanics. It forms the basis for understanding atomic and subatomic phenomena, leading to technological advancements such as electron microscopes and quantum computers. One particularly intriguing outcome of wave-particle duality is the Heisenberg uncertainty principle. This principle states that we cannot simultaneously measure both the position and momentum of a particle with arbitrary precision. The more accurately we measure one property, the less accurately we can measure the other. This inherent uncertainty at the quantum level challenges our classical notions of determinism and predictability. In the business world, wave-particle duality can be applied to understand the nature of disruptive innovations. A new technology or business model can behave like a wave, gradually spreading through an industry and creating interference patterns with existing practices. Simultaneously, it can act like a particle, having discrete, measurable impacts on specific companies or market segments. For example, consider the rise of e-commerce. As a wave, it has transformed the entire retail landscape, changing consumer behavior and business practices across the board. As a particle, it has had specific, measurable impacts on individual businesses, both positive, like Amazon's growth, and negative, like the closure of many brick-and-mortar stores. In psychology, wave-particle duality can be a useful model for understanding human behavior. An individual's personality can be seen as a wave-like pattern of tendencies and traits that persist over time. However, in specific situations, a person may exhibit discrete, particle-like behaviors that seem at odds with their overall personality. This duality is evident in phenomena like cognitive dissonance, where a person's actions, particles, may contradict their beliefs or values, waves. Understanding this duality can help in developing more nuanced approaches to behavior change and therapy. In sociology, wave-particle duality can provide insights into the nature of social movements. A social movement can be seen as a wave, with broad trends and ideologies spreading through a population. At the same time, it manifests as particle-like events, specific protests, policy changes, or individual actions. The Me Too movement is a prime example. As a wave, it represents a broad shift in societal attitudes towards sexual harassment and assault. As particles, it consists of individual stories, specific legal cases, and discrete policy changes in various organizations. Wave-particle duality serves as a powerful mental model for understanding complex phenomena across various fields. It reminds us that seemingly contradictory properties can coexist, and that our perspective often determines what we observe. By embracing this duality, we can develop more nuanced and flexible approaches to problem-solving and decision-making. As you reflect on this concept, consider, in what areas of your life or work have you observed phenomena that seem to exhibit both wave-like and particle-like properties? How might adopting a wave-particle perspective change your approach to understanding and addressing complex challenges? Share your thoughts in a comment below. And don't forget to like this video and subscribe to our channel for more insightful mental models.